Alright guys, this is Mr. Milton. We are going to look at similarities in right triangles, kind of from a different perspective, not perspective I guess. We're going to kind of simplify our process a little bit, hopefully. Today we've looked at similarities in right triangles before, and we've compared their corresponding parts, set up proportions, and solved those proportions, so hopefully we have an understanding behind why this works. And now today we're going to look at I guess just simplifying that just a little bit. Okay, a major part of what we're going to do today is being able to find the geometric mean. Okay, geometric mean, remember, is the number that's the ratio between, or the average between the two numbers when they're multiplied. And so here we go, we have 8 and 32, so we're trying to find the geometric mean between 8 and 32. We set up this proportion, 8 over x equals x over 32. We multiply across, x times x is x squared. 8 times 32 is 256. And then to find x, we take the square root of numbers, and so x will be 16. Okay. Okay, with geometric mean, it's usually positive, but I just want to get in the habit of taking a plus or a minus when I take the square root of a number. And then remembering that if there's any time we're finding a length, then the negative length is not possible, so it would just be the positive outcome. Do the same thing with 15 and 20. Geometric mean between 15 and 20. 15 over x equals x over 15, or sorry, x over 20. Cross multiply, we get x squared equals 300. Take the square root. This time is not a perfect square. If you do the factoring out, we get 3 and 100, and 100 breaks down to 10 and 10, so x will be 10 radical 3. Okay, so just a quick refresh on finding the geometric mean. Alright, so we kind of learned this, or we learned this yesterday. We learned the theorem yesterday. Today we're going to focus on the corollaries, and but we'll refresh ourselves on the theorem. So the theorem involving similarities in right triangles says that the altitude of a right triangle divides the triangle into two similar triangles, or sorry, two smaller triangles, both of which are similar to the original. Okay, and this was the redrawing section that we did from the notes over the weekend. Okay, and so we should see that triangle ABC is similar to triangle ABD. Okay, if I mark these angles as we did in class in the demonstrations, just to kind of remind ourselves that what the corresponding parts are. Oops, I said ABD, sorry. ADB. Okay, because ABC angle B is a 90-degree angle, so my corresponding triangle, I need to have angle D, which is my other 90-degree angle. I need those to match up. So triangle ABC is similar to triangle ADB, which is similar to triangle BDC. Okay, so I should see that B, even though it's not marked, we can kind of by just reason that B has to be congruent to A. Okay, D is 90-degree angle, C. Okay, so that's a similarity statement. We talked about it enough yesterday. If you have troubles with that or you want to see that again, I go further into why that's true on the last video, so feel free to go back and look at that if you'd like to. We're going to move on to the corollaries. Okay, and a corollary doesn't mean shortcut. It means a logical conclusion based off of things you know. So if you know this thing, then the logic, it follows that. Okay, that's what a corollary is. Okay, so here's a corollary that should make your life a little bit simpler if you take some time to remember it. Okay, in a right triangle, and this is referring to the larger triangle, or the largest triangle. Okay, in a right triangle, the length of the altitude to the hypotenuse is the geometric mean of the length of the segments of the hypotenuse. Okay, so breaking that down into what it means. Okay, the length of the altitude to the hypotenuse. Altitude to the hypotenuse. That's this value, altitude, okay, the perpendicular line from the vertice to the opposite side to the hypotenuse, is the geometric mean. Okay, remember geometric mean was where we did a over x equals x over b. It's the geometric mean between the lengths of the segments of the hypotenuse. So let's look at the segments of the hypotenuse. We'll notice that this is the hypotenuse. Okay, these are the segments of the hypotenuse. So what this is saying is that this middle line is always the geometric mean between the two pieces of the hypotenuse. So x, the geometric mean, I like to set it up like this so I can make sure I get it in the right order. So it's the geometric mean between 4 and 9. Okay, and so I can solve for x, cross multiply. X squared should give me 36. And so x, once I take the square root of both sides, will give me 6. Okay, don't have to worry about a negative value because, well, there can't be a negative length. Okay, so that's the first corollary. We looked at it yesterday. And when we did this yesterday, we basically had to draw our triangles out. Okay, and we said, okay, well, this is the short side, and this is the long side, and in this triangle we have x as the short side and 9 as the long side, and so we said, okay, let's set up short over long and short over long and set that up. Okay, we don't have to redraw and do all that stuff in this situation now, because we know that this altitude to the hypotenuse has to be the geometric mean between the two segments of the hypotenuse. Okay, so that should make our life a little bit easier. We'll look at some other ways to do that. What's really nice about this is that by trying to, or by finding those values, we are able to sometimes even only have to do one of these things once. After we find that this value is 6, just because we're here, notice that if we were asked to find these other sides, we could do so just by using Pythagorean's theorem. I could say that, 6 squared plus 9 squared equals c squared, and 6 squared plus 4 squared equals d squared, let's call it. Okay, and so we wouldn't have to use any more ratios or anything. So those shortcuts can make our life a little bit simpler involving these problems. Okay, now let me move this up just a little bit so we can see the bottom of the page. All right, here we go. Now I'm comfortable. All right, here we go. Again, in a right triangle, again we're referring to the largest triangle. Okay, this one is a whole triangle. The altitude to the hypotenuse separates the hypotenuse. Okay, the altitude to the hypotenuse separates the hypotenuse so that the length of each leg of the large triangle, okay, again, a large triangle, these legs, x and y in this case, is the geometric mean of the length of the adjacent hypotenuse segment and the whole hypotenuse. Okay, again, what this is saying, geometric mean, you guys should know it now. A over x equals x over b. It says the hypotenuse segment, the adjacent hypotenuse segment. Remember, adjacent means next to or touching the segment, the part of the hypotenuse that the leg touches. Okay, and the whole hypotenuse. So this is how it works. I'm trying to find x using this corollary. I should know that x is the geometric mean between the segment of the hypotenuse it touches, see this hypotenuse it touches 8, and the entire hypotenuse. Notice that they gave us 8 and 10, but the entire hypotenuse is 18. 8 plus 10. Okay, so if I want to find x, I can cross multiply and solve like I would any other thing, so any other ratio. So x squared is 144, I take the square root, and x is 12. Again, if I wanted to, if I were not doing notes and trying to show examples of why this, examples of this working and working through these problems, I would be able to find y just by using the Pythagorean theorem. Okay, because now my triangle looks like this. I've got 18 for a hypotenuse, I've got 12 for a leg, it's a right triangle. 18 squared minus 12 squared gives me this square, okay, if I wanted to do that way. Okay, but for the sake of the notes, I'm going to go through y the same way, using it as a geometric mean. Y, then, is a leg of the right triangle, so it also is the geometric mean between the adjacent segment of the hypotenuse, and the entire hypotenuse, 18. So y squared will equal 180, and y will equal, what's the square root of that? I might have to actually do that math. 64 times 5, does that work? No, that's too much. 9 times 20. 36 times 5. 36 times 5. Sweet. Alright. Okay, so then I have 6 radical 5. Okay. Remember, there's more than one way to do that. You can just do divided by 2 until you get to the point, but I wanted to not use up too much space on this paper. Okay, and so now you have it that x is 12 and y is 6 radical 5. Okay, using the corollaries and getting to skip out redrawing and setting up those adjacent sides. Okay, because we've already done that, we should see the reasoning behind it. And now, since we understand the reasoning, it's kind of nice to be able to take the shortcut without losing understanding. Okay, flip into the back. Reset this page. Okay. Alright, here's another example. We want to find the values using the appropriate shortcuts. Alright, now here's a tricky one. Because the other two examples, and this happens a lot, the other two examples showed us finding this altitude. Okay. Now what happens is that we have to find x, and everybody wants to just put x as the geometric mean. Okay. Remember, the corollary didn't say that x is the geometric mean. The corollary said that the altitude to the hypotenuse was the geometric mean between the segments of the hypotenuse. So this 6 is our geometric mean in this example. Okay, and I like to start off by writing that twice. Okay. It's going to be the geometric mean between x and 2. Which is nice because we don't have to solve for a quadratic, but it's okay. 36 equals 2x. Divide by 2, x will equal 18. So here we go. We found x. It is 18. Okay. Alright, again, I could use Pythagorean's theorem in order to find y, because 6 squared plus 18 squared should give me y squared. Okay, if you have trouble remembering these corollaries, you can do that. I'm going to use the corollary just because, since I know it, I'm going to use it and show you guys, I guess. So here we go. We have this leg of the big triangle. Okay, y should be the geometric mean between the segment adjacent to it, 18, and the entire hypotenuse, 18 plus 2, which is 20. So I'm going to cross multiply. Y squared gives me 360. All right on that. Okay. hope I'm right on that. Okay, so y squared gives me 360. And so I'm going to take the square root of both. That's going to be 36 times 10. Okay, I know 36 breaks down here. 10 is 5 and 2. Okay, and so y will be 6 radical 10. Okay, which should be somewhere around 18, I think. Okay, just estimating that number for fun, I guess. Okay, if you'd like to, pause the video, try it on your own, this next example. Alright, now I'm going to just go through any order, really doesn't matter. I know it's x, y, and z, but it doesn't matter. I'm going to start with y. Okay, and I'll actually use the Pythagorean theorem after I find y, just because I keep telling you that we could use it and I haven't shown it yet. So I'm going to use y. Y is the geometric mean between these two. It's the easiest one for me to remember. So y is the geometric mean between 4 and 5. I'll cross multiply. Y squared equals 20. And so y will equal 2 radical 5. Okay, so this is 2 radical 5. Alright, sweet. I'm going to use Pythagorean's theorem to find x and z. And so I'll say for x squared will equal 2 radical 5 squared plus 4 squared. 4 times 5 is 20 plus 16 equals x squared. X squared will equal 36, so x will equal 6. I'll do the same thing here with finding z. Z squared will equal 2 radical 5 squared plus 5 squared. So that's 4, that's 20 again. Obviously it's the same number as over there. So z squared will equal 45. And so then z will be the square root of that, which will be 9 times 5. 5 is prime, 9 is a perfect square. So 3 radical 5. Alright. So whether you use the corollaries or you use Pythagorean's theorem, then you should be able to find it. Usually if you are able to use one of the corollaries, the rest of the triangle can be solved using Pythagorean's theorem. Okay, so it's nice to keep in your back pocket. A squared plus b squared equals c squared, if you've forgotten. Alright, now let's look at a challenge problem. Okay. It says at a golf course, Maria drove her ball 192 yards straight at the hole. Her brother Gabriel drove his ball 240 yards, but not right at the cup. For the remaining distances, find the remaining distances for each person. So here's the cup. This is where they started. Okay. So Maria drove it 192 yards and landed there, where the M is. Gabriel drove it 240 yards, ended here, and we want to know how much further they both have to go. So I'm going to put M for Maria, maybe a lowercase m since we already have a capital there. We'll put G for Gabriel. Okay. Alright, so those are my two variables. And so this is still a right triangle, and so we're going to find, I'm going to use the corollaries to find out those distances. Now, this is a little bit difficult because I have a leg of the triangle, but I don't have the whole hypotenuse. Okay, and so this is where people will mess up, I think, the most on a problem like this. But I'll go ahead and show you how this goes. Okay, this leg should be the geometric mean between its adjacent side and the entire hypotenuse. Okay, and so I'm going to say, okay, 240 should be the geometric mean. So I'll write that here. Between its adjacent leg, 192, and the entire hypotenuse. Now I don't know the entire hypotenuse, but I do know it's whatever 192 plus m is. So I'm going to cross multiply with the help of my handy dandy calculator. Say 240 times 240 equals 57,600. 192 times 192m gives me 36,864 plus 192m. Making sure you distribute to both terms here. I'm going to subtract 36,864 from both sides. That gives me 20,736. Okay. Gives me 192m on this side. I'll divide both sides by 192m, and I find out that m is 108. I'll just say yards. So Maria, right, is 108 yards away. Alright, so we could use Pythagorean's theorem in order to find Gabriel, or we could use the corollary. I want to use the corollary because I know this hypotenuse now, and so maybe it's going to be a little bit easier with these large numbers. I don't know. So I'll say, well, G, we don't know. It's a leg of the triangle, so it should be the geometric mean between the segment adjacent to it, segment of the hypotenuse adjacent to it, and the entire hypotenuse, which turns out to be 300. Okay, so I multiply these two, and that gives me 32,400. Okay, equals G squared. And then to find out what G is, I just take the square root of both numbers. In this case, G is 180 yards. Okay. Alright. So hopefully you see that using these corollaries can make life a little bit easier. Less redrawing, less artistic talent necessary, I guess. Also kind of allows you to just jump straight into Pythagorean's theorem a little bit easier. Try it out, and remember that you have to work on it in order to kind of remember it. We'll look at some ways to try to remember it tomorrow, but it's all about practice. See ya.